right, so double and half angles. We'll start with double angle. We've got. So if you have your Carl with you, where's my Carl? There he is. So double angles right up here. So if you have the sine of 2 theta, that is equal to 2 sine theta cosine theta. That's the identity for double angle sine. This is a very common one in calculus. So at the end of the year, just before the AP exam, my calc students will ask, how much of Carl do I need to know? And this is an assumption that you know that the sine of 2 theta is equal to 2 sine theta cosine theta. It's maybe a 50% chance that it'll appear on the AP exam, so this one's pretty significant. It certainly happens throughout the course of the school year where you'll need to know sine 2 theta. It happens a half a dozen times for sure.
So sine 2 theta equals 2 sine theta cosine.
That's right. So if you have the sine of 4 theta, then that would equal 2 sine of 2 theta cosine of 2 theta.
Wait, and then you want to break that down further?
No, well, yeah, you could, but I'm just rewriting it right now. Yeah, you could break this down and break that down. Good question. So if I have 4 sine of 10 theta, what would that equal? I won't use 10 in theta again. That looks like 100. Well, we know sine of 10 theta is equal to 2 sine of 5 theta cosine of 5 theta. And we still have that 4 out front. So it's just 8 times that stuff. Okay, so that's double angle sine. That's going, given the stuff on the left, rewriting it in multiple trig functions. A lot of times you'll see it like this. You'll see 2 sine of 3x cosine of 3x. What does that equal? Now notice, it's kind of what we got on the right side. How do we go backwards? What would that equal?
6
that's going to equal 6 sine 2, or 2 sine 6x, right?
So let's look. If I have 2 sine theta cosine theta, we need a 2 with that, and this quantity here becomes the sine of twice as big as that angle right there. So what did this become? We need a 2, which we have, so that's going to equal the sine of double the angle, which is just 6x. So that was just an example. So another example. Let's say I have 8 sine of 7x cosine of 7x. See if you can figure that out. Write that down.
Like a 14x. No. 4 sine 14x. Because you basically like cut that one in half.
Okay, remember you got to grab a 2, so we do need that 2. And then we need to rewrite this amount, which is what? So Ethan, you were right all along. I just didn't give you credit for it because I didn't want everybody to know that you got it right. Now I'm telling. So it's 4, and now what is all this?
That is sine 14x.
Sine of 14x. Okay, so if you ever see a sine of something times a cosine of the same amount, that should trigger double angle sine. So like right up here, if I have the sine of 2 theta cosine of 2 theta, you can rewrite that as the sine of double the angle. One, then we'll be done with the sine, double angle sine. Yep.
So what if that 8 was, what if it wasn't an even number?
It would just be a fraction.
It would be a fraction.
Yep. Good question. So sine x, cosine x. Well, we're taking the sine of something and cosine of the same thing, so we can make it one trig expression, or one trig function, a double angle sine, but you gotta have a 2 there.
Yeah.
So let's give it a 2. Can I just put a 2 out front?
No.
What do I have to do afterward?
But you can.
What do you say? Take half of it? Yeah, so I'm going to put a 2 there, and I'm also going to put a 1/2 there. So really, 1/2 times 2, I multiplied this amount by 1 here. 1/2 times 2 is just 1. So I haven't changed its value, but now I have a 2 that goes with it.
So you made an overcomplicated 1 to make the other
Exactly.
thing not so complicated.
Yep, kind of like multiplying by the conjugate, top and bottom, that's an overcomplicated 1. We use 1 quite a bit. Okay, so this amount here is what? That's literally the identity. What is it?
Sine x or sine 2x.
Sine 2x, yep. So that's sine of 2x, and then we just can't forget that we have a 1/2 up front. Okay. So that's double angle sine. I went through a few of these examples with other classes yesterday. Today I did a couple of these and they caught on really quickly. Like they were getting them right in their warm-up. So you just have to make sure you do your assignment and ask questions if you get a little confused. I will do,
Is that all?
that's just for sine, yeah. I'll do at least 1 or 2 of these examples tomorrow. I'll try to review everything that we have because your quiz is on Monday. Cosine of 2 theta, this is another double angle, cosine of 2 theta. It actually has 3 different options. We have cosine squared minus sine squared, we have 2 cosine squared minus 1, and we have 1 minus 2 sine squared. 3 different options. But if you start with cosine squared minus sine squared, if you don't want both cosines and sines, maybe you're solving a trig equation that only has cosines in it, you could just rewrite your sine squared as 1 minus cosine squared. So then you could replace that with cosine squared theta minus 1 minus cosine squared theta. So we end up getting 2 cosine squareds and then minus 1. So that's where the second identity comes from. Let's try to stay focused here. Or if you just want to work with sines, you can get rid of the cosine squared, and you can write cosine squared as 1 minus sine squared, and replace that with that right there. You get 1 minus sine squared minus another sine squared, so 1 minus 2 sine squared theta. So 3 different options for cosine 2 theta. You can choose whichever you want. Sometimes it's helpful to choose one of the 3. It should always work, even if you choose one that isn't going to be as easy. Yep, Ethan.
So that equals all 3 of those.
Correct.
Okay.
Yep.
Also, if cosine is kind of like really similar to sine, but not so. Why isn't it? When you change it over, why isn't it cosine like 2 cosine minus? It's just like the same thing. That one with flip flop. I don't know. You can just keep going.
All right. If you can clarify or ask me later, I'll try to help it. So there's a double angle for tangent. Tangent double angle is 2 tangent theta over 1 minus tangent squared theta. Sometimes, well, just know that you can rewrite tangent right there. Sometimes you don't have to use that. I'll explain that with an example. So let's say I have the cosine of theta let's say it equals 8 over 17, and I also tell you that it's in quadrant 2. It's an example. Let's say cosine theta is 8 over 17 in quadrant. That's impossible. So we'll go quadrant. We'll make it negative 8 over 17. Sorry about that. So I want you to find 3 things. I want you to find sine of 2 theta to start with. So take a second and draw your triangle. Label the 3 sides. Do that first. I'm going to pause it. All right, so we have our triangle drawn, quadrant 2. We have 3 sides using Pythagorean theorem. Find the third side, which is 15. This one's negative. It's going to the left. We're asked to find what the sine of theta is. We know the cosine of theta. We know tangent. We know all of them, but we do not know what the sine of 2 theta is. We don't know the sine of 2 theta. So let's rewrite it using our trig function, our trig identities, and we get 2 sine theta cosine theta. That's what Carl tells us. Okay, so now we can find out what sine of theta is, cosine of theta, and then simplify it. Go ahead and try that. So we know sine of theta is 15 over 17. We know cosine theta is negative 8 over 17. So we have negative 240 over 289. Is that simplified? If you frac it, is that what you gives you?
Yeah.
Oh, I got 15 over 17?
What is frac?
When you turn into another fraction.
Huh? I just gave you.
I just multiplied 2 times 15 times negative 8 on top and 1 times 17 times. Like you could just type it in your calculator if you want.
I don't know how that works.
Okay, other questions on that? All right, let's figure out what the cosine of 2 theta is. Same scenario, there's our theta, it's right up here. Figure out what the cosine of 2 theta is. All right, so cosine 2 theta, we have 3 options. Did everyone choose the top one?
No.
Did anyone choose the second one?
Yes.
A couple people did, and third one? All right, so third one's left out. Second one's got a little love. Number 1 dominated. So for me, okay, so if you figure out what the cosine theta is, so cosine squared theta, the notation is a little confusing. This is taking the cosine of theta and squaring it. These are the same thing. Okay, we don't put squared on the end. Why don't I just put the cosine theta squared on the end? This is what it would look like. What is it? Why do we not do that?
So it looks like the theta is squared.
Very good. Yeah, it looks like we're taking the cosine of theta squared. So that's why we don't put the square on the end. We just in math say, oh, I bet if we put it right there, it'll make sense. So that's why the 2 that's considered cosine squared. So we do have to take cosine theta and square it. We know that the cosine of theta is negative 8 over 17 minus the sine squared, negative 8 over 17 squared minus sine 15 over 17 squared. So 64 over 289 minus 225 over 289. What is that? Negative 161 over 289. Anybody else get that? Okay, I see 2 hands. I'm going with it. I'm recording this, so don't make me look bad.
It's not right.
All right. Does that make sense?
Yeah.
Okay, so we're kind of just building off of things that we are. I didn't. No, it was just frozen. Okay, I was recording the screen, just didn't know it. Okay, now screen's making me look stupid. Okay, so if we wanted to find the tangent of 2 theta, we do have an identity for tangent 2 theta. it is 2 tangent theta over 1 minus tangent squared theta. Our Carl right here. If you want to use the identity, that will always work. You can just do 2 times the tangent, which is negative 15 over 8, all over 1 minus negative 15 over 8, or 15 over negative 8 squared, and you get your answer. If you've already, so you can do just using the identity, but the fact that we already know what the sine of 2 theta is, and we know what the cosine of 2 theta is, the tangent of 2 theta is equal to the sine of 2 theta over the cosine of 2 theta. Well, we know the sine of 2 theta is negative 240 over 289 divided by the cosine of 2 theta. And dividing by a fraction, you can just multiply by a reciprocal. 289 over negative 161. So those cross off. We get 240 over 161.
Wait a minute. Is Carl allowed on the ACT?
Not on the ACT, no. He got kicked out.
I don't think they have trig.
All right. This will not be on ACT.
That's mostly algebra.
Okay.
I don't need a math class in general.
Let's do. Yeah, I think that's it for double angle. We'll reinforce it tomorrow a little bit. Do your assignments, and that'll also help you with the understanding. Maybe the last thing that we're going to do today is power reduction, or power reducing. It's in the upper right corner. We've got a sine, we've got a cosine, we've got a tangent. Alright, so sine squared is always equal to 1 minus the cosine of 2 theta over 2. That's just a thing. So if I ask you, so this is the identity for power reduction of sine. If you don't want something being squared, you can reduce it, make it a degree 1 by doing this. So if I have sine square of 4 theta, then that would equal 1 minus cosine of what? What goes in? Yeah, 8 theta. It always just doubles whatever you're taking right there. Okay, so sine squared 4 theta is equal to 1 minus cosine of 8 theta. And the cosine one is exact same thing, except this is a plus rather than a minus. Okay, so that's pretty straightforward. You just rewrite it like this. You'll typically see a problem like this. I'll use x's instead of theta. So how do I rewrite sine to the 4th of x? So sine of x, the quantity to the 4th power. Well, we know that that is equal to sine squared x squared. Right? Sine squared is sine to the 4th. So sine squared, we already know, is 1 minus cosine of 2x over 2 squared. Are you with me? I should do a head count. Like, how many are with me? And in like 3 minutes, how many are with me? Nobody's going to raise their hand. These are kind of nasty. But are you with me so far? You're just rewriting sine squared as this. All right. Now the fun algebra trig begins. We are squaring it. So it's 1 minus cosine 2x over 2 times 1 minus cosine of 2x over 2. So it's a fraction times a fraction. We multiply straight across. This times this, you FOIL, so it's 1 minus cosine 2x minus cosine 2x, so minus 2 cosines of 2x, and then plus a cosine squared of 2x. Negative cosine 2x times negative cosine 2x is this, all over 4. All right. Are you still with me? Did we lose anyone?
I don't like it.
I didn't ask for your opinion. Okay. We're hanging in there. Now, we have to take this. I told you we can't have something squared. We have to rewrite that. We have to do a power reduction inside of it. And the crowd goes wild. 1 plus cosine of 2x over 2. That's what that equals.
That was a fraction on a fraction.
Oh, yeah. So, we now have, okay, if it makes you feel better, I'm going to move that 4 out front. So, it's 1/4 times 1 minus 2 cosine 2x plus the stuff we just did. That's now our cosine squared, so it's 1 plus, oh wait, cosine squared of 2x. I forgot to double it, so that's actually a 4.
Wait, why did it double?
It's a thing. It always doubles.
Oh. Okay.
And that's our answer. Well, kind of. We just got to clean it up quite a bit. So I don't even know the best way. I could distribute the 1, but then I got to pull out a 1/8. Or I could pull out a 1/2 right now. Oh, you call it good? All right, so a lot of you would probably just distribute the 1/4. I don't know if that's the best thing to do. We'll do that.
Oh, did you distribute it?
I distributed the 1/4. I could now distribute the 1/8, and
Is this going to be on the test?
It's gonna be on the quiz on Monday.
there's going to be 10 of these on the quiz on Monday. And the fun continues. 1/4 plus 1/8. Let's see, that's 2/8 plus 1/8 is 3/8. Oh, this is example 5 in the book. Like, you don't have to write it down if you don't want to. But you might miss out on some fun. All right, so that would be a correct answer. For sure, I give you credit for that.
Like there's no more you can do?
Like, you could divide them all by 8 or whatever. Yeah, we'll call that good. Good enough.
It was
Good,
Yeah,
good
what was the starting equation?
enough.
Look at this.
Okay, we start with sine to the 4th.
What's so wrong with that?
Now, isn't this a much better version of it?
What's so wrong with the top?
So you would change it if you can't, if for some reason you aren't, it doesn't help you to have a 4th, like you have to write it in the 1st power. So in calculus, if you're integrating sine x to the 4th, we may not know how to do it, but if you write it down with degree 1, we'd be able to integrate it. So we're manipulating it algebraically and trigonometrically so that you can do what you can do mathematically. Yeah. I added 1/4, which is 2/8 plus 1/8 is 3/8. And